back. Today we're going to talk about inverse trig ratios. An important point of trig ratios is having a calculator available to use in order to find these things, because you could know them, but you have to memorize all these decimals and all that kind of stuff. And so we're going to let our calculator work for us. We're going to use a calculator to find the following. You've probably done this before. Now, on a scientific calculator or on one of these graphing calculators, you have a row of buttons: sine, cosine, and tangent. And what's going to pop up when we find this cosine, sine, and tangent is we're going to have a choice. And we're going to need to make sure that we are in degree mode. Make sure you are in degree mode. And the way that we do that is up by the second button. I don't know if you can see this, but there's a mode button. So we're going to hit mode. And I'm going to draw a little button around it because that's the button you have to hit. And we're going to go down to degree. The general rule of thumb is we're dealing in degrees. The problems are in degrees, so unless it specifies radians, we're going to be working in degrees because we see the little degree symbol. And I'm going to highlight, and I'll hit enter. And degree will be highlighted, and so now I'm in degree mode. When I quit out of that, I'm able to use these functions now to find the sine, cosine, tangent of these degrees. And so what I'm going to push is cosine, and I'm going to put in 37.8. And because it's in degree mode, I don't need to put the little degree symbol. And so I'm going to hit cosine 37.8, and that's going to be equal to 0.7902 rounded to 4 decimal places. Same thing goes for sine, except I'm going to hit sine. I'll put in 58.75. I'll hit enter. So sine 58.75. And I get that that's equal to 0.8549. So you'll notice I'm getting these decimals out when I put in a function. Let's look at this secant. Recall, we're using our calculator, but I notice I don't see any secant function on there. I need to remember exactly, well, what is secant? Secant is 1 over cosine theta. And so the secant of 78 is really going to be 1 divided by the cosine of 78. And so when I plug that into my calculator, it's going to look like this: 1 divided by so I'll type in 1 divided by cosine 78 and hit enter. And I notice that I get an actual value, 4.8097. It really shouldn't surprise us, because we've noticed we've had a decimal here so far when we did cosine, we had a decimal here when we did sine, and so getting a number that has a 4 in front of it is not really surprising, because when we divide by a decimal, it makes the value go up. And so that's how you do that. I would like for you to try these 3 on your own and see what you get. Let's talk for a minute about inverse trig ratios. Your calculator is a big giant database, and what you do is you put in cosine of 50 and it spits out the answer 0.6428, thereabouts. And so in your calculator stores a table like this: cosine, theta. Well, in this case, theta was 50. And it stores the answer in a table alongside it. And so when you put in the cosine of theta, it goes and finds that 50, and it says the answer is 0.6428. And so if I keep going and I do the cosine of 60, is 0.5. The cosine of 70 is 0.3420. Okay, so as I increase those values, it keeps spitting out these decimals. Inverse ratios is the process of taking the decimal and finding what it corresponds to. So in order to find the decimal that it corresponds to, I'm going to have to use the inverse function. Or second, cosine, sine, or tangent. Okay, so those are my options. And what they look like is an inverse. And I know, of course, that the inverse is going to be above, and when I use the second symbol, it's going to look like this. Okay? And so when I'm using that cosine, sine, or tangent with the -1, that means I'm going to be finding an angle. So use these to find angles. So if it's asking me to find the angle, then I'm going to use the inverse. That's going to take these decimals and give me the angle value. Okay? So, for example, let's just do one. If I'm looking at this tangent here, they have given me a decimal. Notice, I don't have degrees. I want theta. I want theta. So I'm going to use tangent -1. So I'm going to hit tangent, or I'm going to hit second, and then tangent, and then I'm going to put in 3.152. So I hit second, tangent, 3.152. And that's going to give me 72.4 degrees, because I'm rounding to the 10th of a degree. I had the tangent value. I use inverse, or second tangent, to find the angle. Let's do it again. I have the sine, which is this big decimal, not an angle. So I'm going to use inverse sine, so I hit second, sine of 0.3733. So theta is going to be equal to 21.9 degrees. Let's try this secant here. Secant, we're going to convert this again. It's 1 over cosine of theta. And so when I'm given this value, it's telling me that 1 over the cosine of theta, this should be a theta, is equal to 1.0768. And so in order to find the theta that's associated with that, I'm going to have to do a little bit of manipulation. Okay, so let's look. 1 over cosine theta equals 1.0768. So if I multiply both sides by cosine of theta, which I don't know, I end up with 1 equals 1.0768 cosine theta. And if I divide by 1.0768, I'm running out of room here, I get cosine of theta, let me write in a different color, equals 1 divided by 1.0768. What does that mean? That means that is my decimal value. So 1 divided by 1.0768 is actually equal to 0.9287. And so I'm going to take the inverse value, or second cosine, of 0.9287. So theta equals 21.8 degrees. That last one's a little bit confusing, but I'd like for you to try this next one. Try these three on your own and see what you can do. Thanks for watching, guys. We'll see you next time.